Hello, Math 06. What we're looking at in this lesson is 10.3, multiplying radical expressions. The little part at the top up here just says that we're assuming everything to be positive. So that's all that is saying. So 1 through 6, it says evaluate the following. All we're going to do is, you can see that these are kind of in line. When you see something like the square root of 4 times the square root of 25, that's going to be the same thing as example 2 here, which is the square root of 4 times 25. And in that case, we're going to get the square root of 100. Now we know that the square root of 100 is going to be 10 because we say 100 is what we call a perfect square. And you'll again notice 3. We have the square root of 9 times the square root of 16, which is going to be the same as the square root of 9 times 16. And if you take 16 times 9 or 9 times 16, you get 144. And the square root of 144, that's also a perfect square, is going to be 12. Now, if you're not familiar with those, if you hit second and the x squared button on your calculator, you'll get the square root and you can type it in. Now, the cube root, we have 8 times 27 because we want to look at these two. Again, it's the same as example 6, which is going to be the cubed root of 216. Now, if you're not familiar with your cube roots, if you press math and then option 4 on your calculator, you can type 216. Again, that was math, option 4, and you'll see that the cubed root of 216 is 6. So now, the product rule for radicals that you see here in the next section, the product rule for radicals. This is saying that you can always multiply the radicands together as long as the index is the same. So you have the nth root of a times the nth root of b is going to be the nth root of a times b. And if you go back up and look at the ones we just did, you can see that in number 1, they're both square roots. Number 3, they're both square roots. Number 5, they're both cube roots. So that's why we're able to do that. So 7 and 8, go ahead, pause the video and try those two out on your own. Okay, you can see that for number 7, we have the square root of 10 times the square root of 7, which is the square root of 10 times 7 to get square root of 70. Number 8, you're getting the cube root of 10. So now what we're going to be doing is kind of going the opposite way with it. Now we're going to be given a radical, and we have to use that product rule to write the radical in simplest form, or the simplified radical form, which means we need to simplify this square root here. So what you want to do is you want to think of your perfect squares. If you're not completely familiar with your perfect squares, think, okay, well, what is 1 times 1? That would be 1. What is 2 times 2? That is going to be 4. 3 times 3, 9. What do we have? 4 times 4, 16. And then 25, and so on. Those are going to be your perfect squares. Those are going to be really helpful with what we're doing in this next part. So now, use the product rule to write the radical in simplified form. So we want to look at this number here, 20. We want to think, okay, which is the largest perfect square that goes into 20 evenly? You think, okay, 16 is less than 20, but 16 doesn't divide into 20 evenly. Neither does 9, but 4 does. So we can rewrite this radical as the square root of 4 times 5, because we know 4 times 5 is 20. Now, like I said, I'm just going the opposite way from here. So think 4 times 5. Now I'm going to write it as 2 separate radicals, like in that previous one. So now we have the square root of 4 times the square root of 5. The square root of 4 is that perfect square. And what's the square root of 4? That's going to be a 2. And then we have square roots of 5. Now, an easy way you can check this in your calculator is to type square root of 20 in your calculator. And when you type the square root of 20 in your calculator, you get 4.472 and so forth. And then if you type 2 square root 5 in your calculator, you get the same exact decimal. That means you simplified it correctly. So what I want you to do is pause the video, and I want you to try out numbers 10, 11, and 12, just like we did the previous one. Use these perfect squares. Again, you want to find the largest one that goes into these evenly. If you need to, go back and rewatch this to get through those. And then you can unpause the video and look at my answers. Okay, go ahead and check your answers with mine. If you need to, pause the video, look at my work. One of the only things I might for C being different is when you looked at number 12, you might have split this into 4 times 8 and had 2 root 8. But keep in mind, 8 you can simplify further because 4 also goes into 8. So just make sure you're careful that your answer is as simplified as it goes. Okay, let's actually go through 128 together. Now, you might think, okay, I don't know what the largest perfect square is. So even if you don't know what the largest perfect square is, start with something that you know goes into 128 evenly that is a perfect square. For example, we know 4 goes into 128. So we could rewrite this, okay, this is the same thing. And if I just do 128 divided by 4, I get 32. So this would be the square root of 4 times 32. Now I can split this up into the square root of 4 times the square root of 32, which would give me 2 root 32. However, we know that, wait a minute, this is not simplified. And this one is actually going to be the same one that we just looked at right here. So now what we're going to do is simplify this even further. So we know that we can rewrite this as 2 times, and this would be 16 times 2. I didn't use a factor tree, so disregard that. And then I say, okay, I still have that 2 out front, and now I have times the square root of 16 times the square root of 2. Well, we know the square root of 16 is going to be a 4 times the square root of 2. 2 times 4 is 8 times the square root of 2. Again, if you're unsure, type this answer into your calculator, type the original into your calculator, and you should get the same thing. Go ahead, pause the video, and I want you to try number 16 here, of the square root of 108. Again, I didn't use the factor tree. If you've learned this previously and you did, that's okay. You can do it that way. But go ahead and try 16, just like I did number 13 there. Okay, you'll notice that we get 6 times the square root of 3. Again, if you need to, pause the video, look at my work, let me know if you have any questions. Now, what I also did is I wrote, you see here in red, 1, 8, 27, 64, 125. These are going to be the perfect cubes, meaning each of these you take a number and multiply by itself 3 times. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, and so forth. We need to be familiar with these numbers in order to easily simplify 14, 15, and 17 here. And we're going to do these ones the same way we did the previous ones. And just now we're looking at cube roots. So we have 128. So you want to look at our perfect cube list and find the biggest number that goes into 128 evenly. Well, we know that 125 is smaller, but it's not going in evenly. Maybe 64. So if you take 128 divided by 64, you'll see that it does go in evenly. So we can rewrite this as the cubed root, oops, can't see my cubed root there. The cubed root of 64 times 2 gives us 128. So that's going to be the cubed root of 64 times the cubed root of 2. And what's the cubed root of 64? That's going to be 4 times the cubed root of 2. Again, make sure that you type it in your calculator to check your answer, and also be careful that when you write your index, make sure it looks like an index. Make sure it doesn't look like a 43 next to your radical there. Okay, again, I want you to pause the video and try 15 and 17. Again, since they're cube roots, you want to look at the perfect cubes. You can check my answers with number 17 then. Now when we actually look at number 15, notice that this is actually the 5th root, meaning we need to figure out how we can simplify this. So we need to multiply a number by itself 5 times. Now whenever you start multiplying a number by itself 5 times, you're going to get a really large number quickly. So it tells you probably want to start with something small. So for example, 2 to the 5th power gives us 32, and we know 32 goes into 128 evenly. So I can rewrite 128 is going to be the product of, and then we're putting this into the 5th root, is going to be 32 times 4. 32 times 4 gives us 128. Now I can split this into 2. We can say, okay, the 5th root of 32 times the 5th root of 4. And the 5th root of 32 is 2, because if you take 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32. And times the 5th root of 4. And that would be your simplified answer there. Now what we're looking at is the same kind of problems, but now we're going to be working with variables. So we have to be very careful here. Now, when we look at number 18, we see y to the 5th power. We know that 5 itself is not a perfect square. However, this variable factor here involves perfect squares within it, because we know something like x squared is going to be a perfect square because that's x times x. You're taking something times itself. So that means y to the 5th, we can create some perfect squares out of that. And what I mean is we can rewrite this as y squared would be a perfect square. Y squared is another one, but we need 5 altogether. That's 2, 4, and then you have 1 left over. Now, when we take the square root of y squared times the square root of y squared times the square root of y. Now, what is the square root of something squared? Well, very similar to how we've been working through anything. What's the square root of y squared? That's just going to be y. The square root of this y squared is going to be y, and then times that square root of y. So therefore, our answer is y squared times the square root of y. Now, you can also think of this as you can do some division here to help you. Say, okay, what is 5 divided by 2? And that's going to be 2 with 1 left over. That's how you want to look at that. Okay, this next one, number 19. Let's see if we can just do a little separator there. Now we have to look at the numerical part and the variable part. So sometimes it's a lot easier if you rewrite it as two separate things. 18 times the square root of x squared. Well, we know 18 is not a perfect square. However, 9 goes into it, and 9 is a perfect square. Times the square root of 2, and then we have the square root of x squared. The square root of 9 is 3, and then the square root of 2 is just the square root of 2. However, we still have the square root of x squared. Well, just like we looked at in the previous one, anytime you have the square root of a variable squared, it's just going to be that variable. So now we multiply this together, reorder it, make it look a little bit nicer. 3x times the square root of 2 would be the simplified form of that. What I want you to do is go ahead and try the last three. Keep in mind 21 and 22 are cubes, and then check your answers with mine. Okay, you can see the answers for these ones here. We get, I kind of ran out of room here, 5x to the 4th times the square root of 7. This one we have y to the 8th. Again, if you did 8 divided by 2, you would get the 4 here. You can see that I did split these up into x squared, x squared, x squared, which the square root of each x squared is going to be an x. That's where the x to the 4th comes from. So if this exponent is an even number to the variable, then there isn't going to be any left. Whereas see over here, this y to the 5th, the 5's odd, so there is one left. X squared is even, so there isn't any left inside the radical. Y to the 8th is even, there isn't any inside. Now, for 21 and 22, since they're cube roots, we want to look to see if they're multiples of 3. Whereas the a here is a multiple of 3, so we know that's not going to be under the radical, whereas b squared will remain because it's not a multiple of 3. And then 22a will remain under the radical, whereas b to the 6th, since 6 is a multiple of 3, it is no longer under the radical. Again, you do 6 divided by 3, and we get the squared here. So go take a minute, look at my answers, look at my work, and let me know if you have any questions on those. Now, we have 7 more examples, 23 through 28. I want to let you just work through those on your own to practice it. We've done stuff like these. The one that might give you the most difficult, maybe number 28 might be the most difficult. Think 25 and 27. You want to multiply the numerical parts first and the variables, and then try to simplify everything all together. Again, you want to multiply first and then simplify. So actually, let's do one of them together just so we can make sure we see what we are doing. So for let's look at number 25. We have the square root of 5x7 times 15x cubed. Well, so for this one, we want to do 15 times 5, and that's going to give us 75. So we have the square root of 75, and remember, x7 times x3 would be x to the 10th. That doesn't look so much like a 10 there. There we go. X to the 10th. Now we think, okay, what's a perfect square that goes into 75? That would be 25. we're left over with a 3. Now x to the 10th, that is an even power, so we know all that's going to cancel. You could think, okay, 10 divided by 2 is 5, so you're going to have x to the 5th. But just to write that out, we know that we're going to have x to the 10th here, just to keep it good. So now let's do all our simplifying. We know that this is going to simplify to just x to the 5th power. So we have 5 from the square root of 25, x to the 5th, times the square root of 3. Again, we could have expanded this part here to say x squared times x squared times x squared, and I'm going to run out of room here, and so forth. And each of these is a perfect square on its own. Okay, now pause the video and do the rest of those, then check your answers with mine when you're finished. Okay, you can check all of your answers there. Everything's pretty straightforward. Number 27, we have the cube root of 21. That does not simplify any further. Number 28, first you had to take the 3 times 2 to get 6, and then I just went down to simplify everything there to get 38 to the 6 times the square root of 2 left. Again, let me know if you have any questions there. Now, the last one that we have here, fire hoses water rate. The rate at which water flows through a particular fire hose R in gallons per minute can be approximated by this formula right here, where D is the diameter of the nozzle in inches, P is the nozzle pressure in pounds per square inch. If a nozzle has a diameter of 2.5 inches, so we want to think of a diameter of 2.5 inches, and the nozzle pressure is 80 pounds per square inch, determine the flow rate, approximate to the nearest gallon per minute, show work. So what we're doing here is working with the formula. So we have R equals 28 D squared times the square root of P. Well, we know D is our diameter, which is going to be 2.5 inches here, and our P is pressure, which have 80. So we need to substitute these values in. So we have 2.5 squared times P, which is the square root of 80. Now this one we're just going to be typing in our calculator because we're not going to be able to do all that in our heads. And when you type all that into your calculator, we get, it looks like 28 times 2.5 squared times the square root of 80 is giving us 1,565.2, rounding to that. But they want us to round to the nearest gallon per minute. So that would be approximately 1,565 gallons per minute would be what we can approximate there. Okay, if you have any questions on anything, please reach out to me, and good luck on your homework assignment.